Hi, welcome to the Mathematics MI channel. Today we are going to solve another interesting integral question. The question is, show that integral from 0 to infinity x raised to 2019 power e to the minus x over hyperbolic cosine of x dx is equal to gamma of 2020 times eta of 2020 over 2 raised to the 2019 power. Okay, first I'm going to define an integral in is equal to 0 to infinity x to the n minus 1 e to the minus x over hyperbolic cosine of x dx. Now we know if we take n is equal to 2020, we will have our integral. Okay, now we can write this is equal to 0 to infinity x to the n minus 1 e to the minus x over, now hyperbolic cosine of x we can write by using exponential function, so we can write e to the x plus e to the minus x over 2 dx. Then we can simplify, so 0 to infinity, this 2 we can write here, so 2 times x to the n minus 1 times, now here e to the x plus e to the minus x, so we can write now e to the minus x is equal to 1 over e to the x over here e to the x plus 1 over e to the x dx. And now we can write integral from 0 to infinity, now here 2 x to the n minus 1, here e to the x, so we can write e to the 2 times x plus 1, and this e to the x, this e to the x get cancelled, here dx. Okay, then now we can use a substitution. So if we take u is equal to 2 times x, now du is equal to 2 times dx, and limit also 0 to infinity, so 0 to infinity, here 2, now x is equal to u over 2 raised to the n minus 1, so u to the n minus 1 over 2 to the n minus 1 over e to the, here 2 times x, so we know u, so e to the u plus 1, here dx is equal to 1 over 2 times du. Okay, then we can write our integral in is equal to, now here this 2 get cancelled, and here we have 2 to the n minus 1, so we can write outside of the integral sign, so 1 over 2 to the n minus 1 integral from 0 to infinity u to the n minus 1 over e to the u plus 1, here du. Well, now here 1 over 2 to the n minus 1 integral from 0 to infinity u to the n minus 1 times 1 over e to the u, we can write 1 over e to the minus u plus 1 du, and then here 1 over 2 to the n minus 1 0 to infinity u to the n minus 1, we can write here e to the minus u over 1 plus e to the minus u du. Now here 1 over 2 to the n minus 1 integral from 0 to infinity u to the n minus 1 times, now for this part we can write, we can use infinite geometric series, so we can write infinite sum r is equal 1 to infinity minus 1 to the r minus 1 e to the minus ru du, and then we can write 1 over 2 to the n minus 1, and the sum we can write here this place. R is equal 1 to infinity minus 1 to the r minus 1 integral from 0 to infinity u to the n minus 1 e to the minus ru du. Okay, then we can write now we can use substitution method. So if we take ru is equal to ru is equal to t, now r du is equal to dt. So our integral in is equal to 1 over 2 to the n minus 1 infinite sum 0 to infinity minus 1 to the r minus 1 integral from 0 to infinity. Now u is equal to t over r, here t over r, so t over r to the n minus 1 e to the, now minus ru, so minus t, here du is equal to dt over r. So then we can write 1 over 2 to the n minus 1 infinite sum r is equal 1 to infinity minus 1 to the r, here minus 1 to the r minus 1 over here r to the n minus 1 power times r, so r to the n, so r to the n power, and then integral 0 to infinity, here t to the n minus 1 e to the minus t dt. Now here we have the familiar functions, so we know here 1 over 2 to the n minus 1 and infinite sum r is equal 1 to infinity minus 1 to the r minus 1 over r to the n. We know eta of n times here this is equal to, we know, gamma of n. Now we need to I of 2020 our integral, so the answer is I rewrite gamma function first, so gamma of 2020 times eta of 2020 over 2 to the n minus 1, 2020 minus 1, 2 raised to the 2019th power. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.